Alright guys, so I'm just gonna walk through getting started with the FizzBuzz Kata and then probably jump ahead to the Whiz section just to kind of demonstrate the idea of a learning test. There are two ways to basically do the bonus section. I'm gonna take the slightly more complicated approach. Let's see if you guys can figure out what the less complicated approach would be. Alright, cool. So I've got my FizzBuzz Whiz test project here. Just a quick reminder, should be using NUnit. If you want to use XUnit, that's absolutely fine. They're both incredibly similar. For right now, remember I've got the three projects. I've got the test SDK, NUnit, and Unit 3 test adapter. Obviously, the XUnit a test adapter if you're using XUnit. Still in the realm of really simple assertions, so we'll just be using the built-in assertion library with what we have. Our chosen framework provides. So kind of got the basic shell here, got the test class, got a test named test. Oh, actually I didn't put the test attribute on it. There we go. Now I have a test named test with the arrange, act, and assert. And over on my right-hand side, I've got my test cases with the input. Remember, this is a guided Kata. It's all about triangulation, and that's why I want to get you started. I think one of the biggest mistakes people make with this Kata is just going through the test cases in sequential order. You miss the whole point of working with the triangulation pattern. You're just kind of plugging away at things, and eventually you find out because it's such a small Kata. Cool, so first thing I'm going to do is figure out what I want to rename this to. So let's say FizzBuzzer. That'll be my method name. And then I'll say when input 1, expect 1. Something along those lines. Method, scenario, expected. So let's start off here. So I'll say var input equals 1. Var sut system under test is equal to new FizzBuzz Whiz. So remember, compilation failures are first-class test failures. Alrighty, so I had to go back and change from FizzBuzz Whiz to FizzBuzz because apparently it was some kind of namespacing conflict issue. I don't know, maybe a name thing. Oh, the FizzBuzz Whiz, of course. Okay, anyway, so compilation failures are first-class test failures. I've made that come into existence, so I had to stop writing code, make enough production code to make it pass. Now I'm back into a good place. Then I can say var actual equals sut dot FizzBuzzer, and I'll give it my input. Putting an input variable may have been a slightly premature step, but as someone who does a lot of testing, I know it's going to be somewhere I end up, so that's fine. Once again, I've got the same issue. I've got a compilation failure, just enough code to make it pass. I'm cool. So the expected is 1, and now I should be actual dot, oh, sorry, assert dot r equal, kind of fell back into the fluent assertions. The expected is equal to the actual, and there we go. So let's run the test. Run test. I mean, it's all going to be pretty straightforward at this stage. I don't think anyone's going to have any real questions. Let's hope I have. Oh, fantastic. Made it all come together. I got a not implemented exception. Oh, that's horrible. Well, let's go make that test pass. So what's the least amount of code I can make this pass? Because remember, regardless if I'm using a fake it or triangulation, I'm still taking these really small steps to get there. So I return 1. I go run test, and voila, it works. So now I can do my refactorings. I'm sure there's a few things we noticed that we want to clean up. The silly public constructor, the signature on this, and this. Now I'm going to go run these. Yay, it all comes together. Cool. Now I'm going to copy this, go to my next test. When input 2, cannot spell, and output 2. Cool. Input 2, expect 2. I'm going to run my test. I should see 1 failure. Oh, I do. It was incorrect. So now I can say something like if input equal 1. I always put my braces just because I'm old school. Return 2. I know it's syntactically valid not to, but believe me, I've been around long enough to see all kinds of problems result from that. Cool, they both pass. Any refactorings? I would say no. I'm only on step 2, 3. I know I'm triangulating, and remember it's about staying in that same equivalence partition. So in this case, the number's not divisible by 3, 5, or 3 and 5. It's going to return the value. I'm going to go to input 4. So you can see here I've skipped over 3 and went to 4 because I'm trying to stay in that same equivalence partition. Expect 4. Change that. Change that. Run my test. Kabam! Got a failure. Oh noes. What should I do? Well, I'm going to do the weird concretized implementation that feels awkward, because remember, I only really want to refactor after my 4th one. It's all about getting it passing. So ideally, the idea behind triangulation is you can kind of pinpoint an implementation or pinpoint that portion of the algorithm. So what I've done is I've got everything passing. Looks 4, 4, 4. Everything looks good. What can I do to simplify this? Well, if I try input.toString, does that also solve the problem? Bam! Look at that. It still works. I've simplified my implementation. I've dialed into that piece of the algorithm by using this idea of triangulation. Like I said, triangulation fake, it kind of in the same category to me. Maybe someday I'll get to speak to Kent Beck again and kind of figure out what his nuanced thinking was around that. Or maybe I'll reread the book. I don't know. Cool. So now I've got another specific uniqueness on my hand. I've got 3 tests representing the exact same concept. Do I need all 3? No, I don't actually need all 3. In fact, the next refactoring I can do is probably to kind of roll this up into one scenario. So I could say something like when input not by 3 or 5, expect input as string. Now I would say just that act right there has kind of brought me back to let me make or smaller. Brought me back to that point of triangulation. Am I able to name the concept? I better understand that equivalence partition I'm working with and what the expected output is. So now I probably want to go delete these because they're not really adding a lot of value. And you may say, hey, look, you had 3 values, now you're down to 1. Well, remember, it's the same equivalence partition. I don't actually need to input more than 1 value. Now, at this stage, you may not be fully comfortable with that. You may want to do something like making a test case or a theorem. Excuse me. So we'll convert this over. This will be input and string expected. Sorry, it's just getting a little far off. Okay, so now I'm going to go take my input variable out and my expected out. I'll run the test. Cool, my 1 test passes. So now I want to bring the other 2 back online. So the only time you should ever use a test case is literally if you're dealing with the same equivalence partition or you're testing the same boundary. If you're dealing with different partitions, they're 2 different scenarios. They're giving you different outputs. A test case isn't your friend. A test case isn't here to simplify apparent duplication in code. It's to simplify expressing the various inputs into a particular equivalence partition that give you a singular expected output. So do not abuse them as some kind of shortcut for not needing to write code. Please, please, please do not do that. All right, so I'm going to bring 2 back online. I'm going to do the same thing. And obviously 4 is the next one. So I'd imagine for each of these equivalence partitions, you're going to do the same thing. You're going to write 3 tests, very concretized like I was, given 1, expect 1, given 3, expect fizz. And then you'll probably roll them up once you find that more generic implementation into one test. You may or may not put test cases there. I'm doing this very explicitly to have this discussion around test cases and their purpose and kind of how they align to this equivalence partition and boundaries thinking. Let me run the test. So I should have 3 out of 3 passing. I don't know why that one's not running. Oh, okay. Something weird about my test runner. I don't know why. Okay, so the final refactoring I'm going to do is I'm going to take out these previous other 3 super concrete examples. So now the next thing I would do is probably pick fizz, the fizz partition, work through those examples, and carry on. Which then brings us to, let me just expand this, brings us to the Whiz Rule. I say only worry about numbers up to 100, so I said there's 2 implementations, the more slightly complicated one and the probably more trivial one. But I will focus on the more complicated one because it allows me to better express the idea of a learning test as it relates to the reverse gear. So remember, red, red, revert. And so if you try 2 times and you can't get it working, time to back up. Or even if you feel like you're taking too big of a step, it's struggling to really figure out how to write a good implementation quickly. I mean, if it's taking more than a few minutes, it's taking too long. So we're going to jump forward to that in just a second. All right, so I've plunked in my learning test. So pretend, let me go. All of the tests are there, the implementation's here, and now I've gotten to this really weird requirement where it's like, hey, you need to detect prime numbers and, do some other behaviors. Okay. The first thing you're going to see is 2's prime. So, instantly 2's going to come out of here and come into a different test. But, for the example of explaining a learning test, we're going to say that's the one I picked. I tried. I failed. I'm just stuck on how to actually get this figured out, so I'm going to pull out an implementation and just focus on that core essence of the problem. That's what it's all about. I've got my failing test for the scenario. I'm trying to make this happen. You know what? In fact, let's just be diligent about this. Let's put that test in. FizzBuzzer when input prime. Let's say input 2. Because we're still concrete. We're still exploring this new concept. Expect whiz. I'll obviously go comment this out. All right, so here's the better setup for the scenario. I've got my test, my var expected equals whiz, and my var input equals 2. And then we can take these out of here. All right, so that's what it should be doing. Obviously, it's going to fail. So we've tried. We just can't seem to figure out how to make the implementation come together in the FizzBuzz class. So I'm going to pull out a learning test and focus on that. Now, this is the actual implementation I have. Obviously, I jumped here because I've got it sitting somewhere in a solution, but the idea would be that you kind of iterate within this one test to find that concept, to figure out how am I going to drive it at figuring out the prime numbers that I need to worry about. So in this case, I'm going to make a candidate number. I've got the expected true, so this is using kind of an older style of having the expected in the arrange. I don't do that anymore, so we'll put that down. We'll run our test. Let's just see what our learning test tells us. Oh, cool. So it tells us that it looks like we can at least detect 2 as a response. So let's go put it in. Well, first we're going to uncomment our specific test, put it in. Okay, candidate number. So this probably changes to input, input, and input. And I could say something like if is prime return Whiz. Let's check all our tests. Cool, it's working. So remember, it's gone green because we were under a scenario where this was red, this was red, this was red. It wasn't working. And now we've got it to a stage where it's working. At this point, I'd probably remove this test or ignore it at least. Maybe I haven't quite solved the problem. 3's next on the horizon. It's going to have some potentially more nuanced ways of going about it. But that's the idea. You're struggling. You literally just pull out that bit of logic that you're trying to work on. Focus on it. Once you figure it out, bring the test that you were struggling with back online or write a new one. If I had taken the more, let's get the test to fail. So red, green. Let's run that test without that implementation. Obviously, it's failing. Bring that implementation back online, and now I know that it's all good. It seems to be working. Like I said, this is the slightly more complicated version. There's probably a very much easier way of addressing this portion of the problem. And one thing I'd like to point out, there is an inherent boundary here. The rest of it doesn't really have boundaries, but there is definitely one new boundary, and that's only worrying about this behavior up to 100. So I should see a test for that boundary and the other equivalence partition. Interesting. Or at least the new equivalent. Yeah. Anyway, I'm sure you guys will have lots of fun with this one. It's pretty straightforward. It's pretty simple. I'm not going to dive too deep into any more of this. I'm expecting solutions. I can do the review then. Age calculator, try your hand at it. Same kind of concept, just not guided anymore. It's literally the same kind of concept. But like I said in the other video, I'm likely to hop on a call, hopefully not tomorrow, hopefully next week, and at least spend a little time talking through that, because I think this is where the rubber really starts hitting the road, even if you are familiar with TDD. And if you're not, maybe the wheels start to fall off the bus a little bit. But anyway, have fun, good luck, and go team!